Hello friends, today we are going to start with chapter 15 titled as Communication Systems. The mind map of the chapter is like this. First we'll take up radio waves, then we'll talk of antenna. In the third stage we'll take up some preliminary definitions regarding communication system. In the fourth step, we will try to understand about modulation, and in the fifth phase, we will try to learn basics of computer, that is modem, fax, data, email, file transfer, e-commerce, and mobile telephony, etc. So according to this mind map, we will be proceeding to learn about communication system. That is the basics of communication systems. Okay. Now we start with part by part. First we take up communication systems part 1, radio waves. So what are radio waves? Let us try to understand. Electromagnetic waves with frequency range 3 into 10 raised to power 5 Hertz to 3 into 10 raised to power 11 Hertz and wavelength range 10 raised to power 3 meter to 10 raised to power minus 3 meter constitute radio waves. I repeat, electromagnetic waves with frequency range 3 into 10 raised to power 5 Hertz to 3 into 10 raised to power 11 Hertz and wavelength range 10 raised to power 3 meter to 10 raised to power minus 3 meter constitute radio waves. Now, propagation of radio waves. Now we take up part by part. So first we take up communication systems part 1, radio waves. What are radio waves? Let us define. Electromagnetic waves with frequency range 3 into 10 raised to power 5 Hertz to 3 into 10 raised to power 11 Hertz and wavelength range 10 raised to power 3 meter to 10 raised to power minus 3 meter constitute radio waves. I repeat, electromagnetic waves with frequency range 3 into 10 raised to power 5 Hertz to 3 into 10 raised to power 11 Hertz and wavelength range 10 raised to power 3 meter to 10 raised to power minus 3 meter constitute radio waves. Okay. Now propagation of radio waves. How radio waves propagate? Now radio waves are electromagnetic waves and propagate through space with velocity of 3 into 10 raised to power 8 meter per second. When radio waves propagate through Earth's atmosphere, its intensity reduces with distance from generating transmitter. Since intensity is directly proportional to amplitude square, therefore amplitude of electromagnetic wave propagating through Earth's atmosphere is given by the expression Et is equal to E max sine omega t minus k dot r, where k is equal to 2 pi by lambda, called as wave vector, and vector r is equal to I cap x plus j cap y plus k cap z. That is, it is three-dimensional vector and the electromagnetic wave propagates along 3 dimensions and its amplitude reduces with distance from generating transmitter, because here we have the term omega t minus k dot r. Its amplitude goes on reducing with distance r. Now, factors affecting propagation of radio waves. There are 3 main factors which affect propagation of radio waves. Number 1, frequency of operation. Number 2, topography of the region like desert, hill, terrain, metro cities, vegetation, forest area and oceanic region, etc. Third is power of transmitter. I repeat, factors affecting propagation of radio waves are number 1, frequency of operation, number 2, topography of the region, number 3, power of transmitter. Now, classification of radio waves. Atmosphere behaves differently to different radio waves. Therefore, on the basis of behavior of atmosphere towards radio waves, the waves are classified into three categories. These categories are: number one, surface waves, or ground waves, or long waves, or medium waves. So, ground waves, long waves, medium waves are the names of surface waves. Number two, sky waves or short waves. Number three, space waves. First, we take up surface waves. The radio waves with frequency range 500 kHz to 1500 kHz and wavelength range 600 meter to 200 meter constitute surface waves. I repeat, the radio waves with frequency range 500 kHz to 1500 kHz and wavelength range 600 meter to 200 meter constitute surface waves. You can calculate wavelength from the formula as C is equal to nu lambda, where nu is frequency and lambda is wavelength, C is velocity of light, which is 3 into 10 raised to the power 8 meter per second. You can calculate wavelength. Okay. Now, features of surface waves. A. Surface waves propagate near surface and induce charges in earth, which travel with the wave and constitute surface currents. That is why these are known as surface waves or medium waves. B. Surface waves cannot travel long distance because of attenuation due to surface currents. C. These are absorbed by ionosphere. D. These are used for local broadcast or commercial service. E. Range of communication is between 30 to 120 km. Now, assignment 15 starts. Question number 1. Why ground wave signals are restricted to frequency 1500 kHz and not above? Number 2. Sky waves or short waves. The radio waves with frequency range 3 MHz to 30 MHz, wavelength range 100 meter to 10 meter constitute sky waves, also known as HF communication, that is high frequency communication. I repeat, the radio waves with frequency range 3 MHz to 30 MHz and wavelength range 100 meter to 10 meter constitute sky waves, and these are also known as HF communication system. HF stands for high frequency. Sometimes we call it as HF communication system, that is high frequency system. Now, features of sky waves. A part. Sky waves propagate to sky and are reflected by ionosphere towards earth. That's why these are called as sky waves. B. Sky waves cannot travel via ground because of high attenuation. C. Plasma frequency is given by the expression Fp is equal to 9 into under root n, where n is number density of electrons in ionosphere. Any radiation of frequency Fp that reaches the region of electron density n at normal incidence, it will be reflected, as shown in diagram. You look at this diagram. This is ionosphere, this is transmitter, this is receiver. So, any frequency that reaches ionosphere from transmitter, it is reflected towards the receiver from the ionosphere. Okay. This is how sky waves propagate through atmosphere. Thus, the radio waves of different frequencies sent from Earth would be reflected back from appropriate layer of ionosphere. The critical frequency for reflection is therefore Fc is equal to 9 into under root n max, where n max is the maximum number density of electrons for a particular layer. For E layer, Fc is equal to 4 MHz. For F1 layer, Fc is 5 MHz. For F2 layer, Fc is 6 to 8 MHz. D. Sky waves are absorbed by Earth. E. Used for long distance broadcast. F. Range of communication is thousands of kilometers. Here we come across a term skip zone or dead zone. So what is skip zone? The region between transmitter and receiver where no any signal of sky waves are received is known as skip zone or dead zone. I repeat, the region between transmitter and receiver where no any signal of sky waves are received is known as skip zone or dead zone. Okay, here you can see in the diagram this is dead zone or skip zone. This is transmitter and this is receiver. So between transmitter and receiver there are no signals. So this is called as skip zone or dead zone. Assignment 15 continued. Question number 2. Why short waves are used for long distance broadcast? Question number 3. Why short waves cannot be used for ground wave communication? Question number 4. Define critical frequency. Question number 5. A radio can tune to any station in 7.5 MHz to 12 MHz band. Calculate corresponding wavelength band. 3. Space waves. Now we try to understand about space waves. The radio waves with frequency 30 MHz to 300 GHz and wavelength range 10 meter to 10 raised to power minus 3 meter constitutes space waves. I repeat, the radio waves with frequency range 30 MHz to 300 GHz and wavelength range 10 meter to 10 raised to power minus 3 meter constitute space waves. And now features of space waves. Let us look at next slide. Now features of space waves. A. Space waves travel parallel to surface of Earth in troposphere. B. Space waves are reflected by Earth's surface and penetrate ionosphere. C. Space waves provide line of sight communication. Line of sight means aerial, transmitter aerial and receiving aerial must see each other directly or indirectly. D. Uses of space waves. Space waves are used for number 1 FM broadcast, number 2 television, number 3 mobile phones, number 4 radars, number 5 microwave repeater stations, number 6 microwave ovens. E. Range of communication. Range of communication depends upon line of sight, that is topography of regions, because Earth has undulations. Somewhere there are hills, somewhere there are deserts, somewhere there are forests, some there are water bodies. Therefore it depends upon topography of the region, that is line of sight. If line of sight is there, then it can extend to many kilometers. If a line of sight is not there, it may not be even 1 kilometer. Okay. F. Spectrum of space waves. Spectrum of space wave is divided as under. Look at this table. It has 3 columns. First column is frequency range, second column is wavelength range, and third column is range name. Now first, frequency range of space waves is from 30 MHz to 300 MHz and wavelength range is 10 meter to 10 raised to power minus 1 meter, and we call it as VHF, very high frequency. Second, 300 megahertz to 3000 megahertz, that is 3 gigahertz. Wavelength range is 1 meter to 10 raised to power minus 1 meter, and its name is UHF. ultra high frequency. Third, 3 gigahertz to 30 gigahertz. Wavelength range is 10 raised to power minus 1 meter to 10 raised to power minus 2 meter, and its name is SHF, super high frequency. Also we call it as terrestrial microwaves. Fourth, 30 gigahertz to 300 gigahertz. Wavelength range is 10 raised to power minus 2 meter to 10 raised to power minus 3 meter, and its name is EHF, extremely high frequency, or sometimes we call it as microwaves. Okay, so this is how spectrum of space wave is divided. G, allotment of spectrum of space waves for radio communication. Look at this table. This table have 5 columns. First column is type of communication, second column is frequency range, third column is band, fourth column is channel spacing, and fifth column is number of channels it accommodates. Now first type of communication we come across is FM broadcast type of communication. Frequency range of FM band is 88 to 108 megahertz, and the band is VHF. It is in VHF range, and channel spacing is 40 kilohertz. For all sound wave communication, we have in space wave channel spacing as 40 kilohertz, and number of channels accommodated in the FM broadcast is 500. Now second, television. Television operate in different frequency ranges. So first range is 40 to 68 megahertz, and we call it as VHF. Channel spacing is 7 megahertz, and number of channels accommodated are 4. Now here channel spacing of 7 megahertz is divided into 5.5 megahertz for video and 0.5 megahertz for sound frequencies, and then 0.5 megahertz at the upper limit and 0.5 megahertz at the lower limit for safety. So total comes out to be 7 megahertz. Now second range, TV operates between 174 to 300 megahertz. Again it is VHF range. Channel spacing is 7 megahertz, and number of channels accommodated are 13. Third range is 470 to 582 megahertz, which is in UHF range, and channel spacing is again 7 megahertz, and number of channels accommodated are 16. Now fourth range of television is 606 to 790 megahertz. Again it is in UHF range. Channel spacing is 7 megahertz, and number of channels accommodated are 26. This is how spectrum of space waves is allotted for operation of television communication. Now third, mobile phone. The frequency range of mobile phone is 800 to 900 megahertz. It is in UHF range. Now mobile to base frequency is 840 to 935 megahertz, and base to mobile is 840 to 901 megahertz. Now fourth, radar. Radar also operates between different frequency ranges. So first range of radar is 225 to 390 megahertz, which is some part is in VHF and some part is in UHF, and we call it as P band. Another range of radar is 390 megahertz to 1.55 gigahertz. It is in UHF range, and we call it as L band. Next range is 1.55 to 2 gigahertz. It is in SHF range, super high frequency range, and we call it as S band. Another range is 5.2 to 11 gigahertz. It is also in SHF range, and we call it as X band. Last one is from 11 to 30 gigahertz, which is also in SHF range, and we call it as K band. Now fifth is satellite communication. Type of communication is satellite communication. Satellite communication operates from 30 to 300 gigahertz, which is extremely high frequency. It is in EHF band, and we call it as microwaves. Okay. Now assignment 15 continues. Question number 6. Identify the part of electromagnetic spectrum to which the following wavelengths belong. First is 10 raised to power minus 1 meter. Second is 10 raised to power minus 12 meter. Third is 1 millimeter. Fourth is 1 angstrom. Fifth is 10 raised to power minus 2 meter. Now microwave oven. Microwave oven is a kitchenware used for instant heating of food items using microwaves. Any food item containing water is placed in a non-metallic utensils and rotated in the field of microwaves. Since water molecules can vibrate at frequencies equal to microwaves, resonate at frequency of the microwaves used in oven. The water molecules in the food item vibrate at maximum amplitude due to resonance, resulting into collisions among themselves, raising the temperature of the food item. I repeat, any food item containing water is placed in a non-metallic utensil and rotated in the field of microwaves. Since water molecules can vibrate at frequencies equal to microwaves, they resonate at frequency of the microwaves used in oven. The water molecules in the food item vibrate at maximum amplitude due to resonance, resulting into collisions among themselves, raising the temperature of the food item. Okay, now question number 7. State the condition under which a microwave oven heats up a food item containing water molecules most efficiently. Thank you so much. Next time we'll take up second part of it, antenna. Till then, goodbye and good luck to you.